Hello everyone. In this lecture, I am going to discuss the race around condition in JK flip-flop. It is one of the issue in JK flip-flop. So let's discuss. We are already aware about the behavior of JK flip-flop. So when the clock is 0, these value of J and K, they become don't care, and we get the previous state. Now in case the clock is high, it is having value 1, and in case J and K both are having value 0, then it will act as memory element and we will get the previous state. But in case the clock is high, J is 0, K is 1, in that case we will get value 0. And in case clock is high, and if we have J as 1 and K as 0, in that case we will get value as 1. But in the last case, where we were having the problem in SR flip-flop, in case both J and K are having value 1, then we need to predict the state. So in this, it is a toggling. We consider it is toggle. So if it was Qn, it will give you the complement of Qn. So Qn can be 0 or 1. So let's understand this with the help of the clock pulse and with the help of this diagram. So let's draw the clock pulse. So we have something like this, and we are assuming that generally we face such kind of issue when the flip-flop is level triggered. So I assume here the flip-flop is utilizing level triggering. Okay. So in case of level triggering, when the clock is high, then the deflection will be shown on these pins, right? So let's consider we are having, so there is a pulse I'm considering for J. So because J is 1, it will come like, let's say it is high only. So this is for J, and it is high only till the end. Similarly for K also I can draw the same thing. K is also high only. Now when it comes to Qn plus 1, so let's look at when it is low, the pulse is low. So previously whatever the value you have, you consider, let's say it was 0. Okay. So let's say in this period it was low, in this duration. So let me write, this is representing J pulse, this is K, and this is Qn plus 1. Now once it will become high, the pulse will become high, and because this flip-flop we are assuming is level triggered, so it will become high. So we will get the deflection and it will become high. But in this duration from here till here, the pulse is high only. So this last condition, which is 1 1 1, it is true in this particular duration. And this duration is actually, because this is time period, it is the half of the time period. So it is T by 2 time. It is T by 2, right? So in T by 2 time, this toggling condition is true. And that means if here we are having 1, after some time we will get 0, because it will toggle again. So there will be a delay as per the propagation delay, and then it will become 0. And after 0, because again this same condition is true, 1 1 1, because pulse is 1, J and 1, Q is 1, again it will change toggle and it will get value 1. then again the same situation. So again from 1 to 0 it will toggle, then again from 0 to 1 it will toggle, then the same situation will occur in this duration t by 2. Now after that it will be low, and again in this period here, in this period again the same situation will occur. So here it will again start getting high value and then low value, then high value, then low value. So this situation we consider as race around condition. So this is a race around. Okay. So this is one of the problem in JK flip-flop. So this is undesirable. We don't want such kind of fluctuations. So there are ways how we can deal with race around condition. So the solution to race around condition. So what is the solution to the race around condition? There is very first situation in which we consider that this t by 2 time is less than the propagation delay of these gates. So the propagation delay of these gates means it will take some time to reflect the deflection or changes. So if your clock is changing in less period of time than the propagation delay of gate, this fluctuation will not be reflected here at qn plus 1. So the very first condition is when t divided by 2, what is t? T is the time period. So here it is mentioned time period. It should be less than the propagation delay of the gate. Right? Second case is we can use, rather than level triggering, we can use edge triggering. Okay. So in edge triggering, because this pulse will become high and the scenario will not like that, so this one will keep on, will not be setting as 1. Again it will reflect 1 here. So on these, either the positive edge triggering we can use or negative edge triggering, but in that case race around condition will not occur, right? And the third solution to race around condition which we can incorporate, that we can construct a master slave concept in JK flip flop. So master slave flip flop is one of the solution. In master slave flip flop we use two JK flip flop, one as master and another flip flop we can use as slave. Okay, so we will discuss in the coming lectures the working of master slave also, and we will also try to understand how it will control the race around condition. So it is sufficient for the lecture. Thank you everyone for connecting.